Hello everyone, welcome to the second video of my machine learning tutorial series. In my previous video, I have introduced what is machine learning and talked about machine learning types and the workflows. So in this video, I will explain to you one of the most common supervised learning type that is regression. We will explain what is regression, and we will also see some hands-on code using scikit-learn to show how regression is implemented. So let's dive into the video. So today we will work with this data set called, so the name of this data set is California housing price. So first of all, we need to get some idea about, we need to get some domain knowledge about the data set before we dive into the code. So as you know, regression actually predicts some continuous values or something like, for example, some prices. So something like house price or something like age, unlike classification. So in classification, there we predict discrete values, like, for example, from an image, whether the image is a cat or a dog. But in regression, we predict some values, some continuous values. For example, housing price, height of a person, or something like this. So in this data set, our main aim is to predict the median house prices for California district. So this is data set is derived from 1990 census. You will get this data set in Kaggle. I will also leave the link of the data set in the or description section. So if we just read that this is the what it says. So okay, so what is this data set contains. So it will help us to predict the current housing prices. So the data set has this type of columns: longitude value, latitude value, house median age, total rooms, total bedrooms, population, household, median income, median house value, ocean proximity, etc. So these are the details that what longitude means. What so the data set is actually like this. So there are several values. There are 10 columns and a lot of rows. There are longitude, latitude, ocean proximity, etc. So let's see the code now. So for regression, we need to first have we need to now gain some knowledge about the data, as I mentioned earlier. So this is actually has these features, and also there is population data and also median house pricing data. So first of all, in our machine learning pipeline, our machine learning workflow, after gaining knowledge about the data, our second step is to frame the problem. So we need to know that the problem is a supervised learning task or a regression, or whether it is an unsupervised learning task or a regression task. We need to know all those things. We need to frame our problem. We need to know whether the problem is, how we will solve the problem, because if we know that whether the problem is supervised learning or unsupervised learning, it will help us to solve the problem. So this is the first step before starting our code. So Since their levels are given, so obviously this is a supervised learning task, and also we will predict a value, so this is a regression task. So also this is a multivariate regression, so there are multiple features are used for this prediction. So this is also called multivariate regression, and our target value which we will predict is the median house price. So also we need to consider that what will be our performance measure. So in machine learning, we there is levels. In supervised machine learning, the levels are given, so we will have to compare the difference between the predicted value and the actual value. That is the predicted level and the actual level. So a loss function will be there which will calculate the difference between our prediction and actual value, and it will continuously try to improve the prediction. So for regression, we usually use root mean squared error. So it actually measures the standard deviation of the errors and find if there are any outliers. So this is the good choice actually for regression task. For classification task, there might be other performance measures. The mathematical formula for root mean square is actually nothing but this is the difference between the predicted value and the actual value, square difference between the predicted and the actual value, and then we calculate the root after calculating the square difference. So we need to further think, and we need to analyze and deeply think that whether our all our previous assumptions are correct or not. So after that, we can move into the data expression part. So this is very important for any for solving a machine learning problem. We need to export our data first. So exploring and visualizing data will allow us to know more about the data, how the data is arranged, what are the variables, what are the values. It will help us to find if there are any missing values in the data, and whether the data is categorical or numerical. So these kinds of things and information on how the data is distributed we can know. So if we so here we can see that for data expression we have first imported some libraries like matplotlib, numpy, sklearn, etc. And then we are using the pandas library to load our dataset. So after loading our dataset, we have named the variable as housing. So housing dot head gives us the first five values of the dataset. So here you can see that the longitude, latitude, and the values on the house, median age, total rooms, how many rooms are there, total bedrooms, population, household, median income. So this is our target. Uh, I mean, there is median house value. So these are our features, and median house value is our target value, which we will predict. And there is also information about ocean proximity, that whether the houses are near the ocean or far away from the ocean. So there are data like this in the dataset. So these features will help us to actually predict the median house value. So of course the total rooms or bedrooms, these things will increase or decrease the price, right? So there is another pandas method called housing.info, which is used to actually know more information about the data set. So it gives information like how many columns are there, how many rows are there. So there are 20,640 rows starting from 0 to 20,639, and there are columns called latitude, longitude, total bedroom. So there is we can see that there is no non null, so they are all non null. So that means there no null values, and all values are float 63 except the ocean proximity, which has a data type object data type. And also we can see that the memory usage is 1.6 plus MB. So 1.6 MB is the whole size of the data set, the memory it occupies. So we can get this sort of information from housing.info method. This is a built-in method of pandas core frame data frame class. So then we can also, using the we can also call the ocean proximity column and count its value using this method. So explaining the Python codes and all other stuffs are actually out of the scope of this video. You can refer to my previous videos on how to write Python, how to code Python lists and all other stuff. For that, you can refer to my other tutorial series on data science. So you can see that actually there are several possible values for ocean proximity. So some houses are near the ocean, some houses are near inland, some are near the ocean, near bay, and some are also in the island. So it has shown the distribution that how many houses are there which are near the ocean, how many houses are there in the inlands. So you can see that there are 2,658 houses near the ocean, and near island there are only 5 houses. And also it shows the data type of ocean proximity. So actually it is showing the data type of the count values here, not the ocean proximity data type. Ocean proximity is object data type as we have seen above here. So it is integer 64 values, these values. Then there is another built-in method of pandas data frame, that is housing.describe. So it actually shows a lot of other informations like mean, standard deviation, mean, the 25% quartile, 50% quartile, and the maximum values. So here we get another important information like count. So there are count of total bedrooms. Okay, so we have seen this previously as well, that some total bedroom values are actually missing. So what is the reason for this? That there are 20,640 rows for all other features or columns, but 20,433 for total bedrooms. So we will check why this discrepancy is there. So basically this is also shown here. Some actually there are maybe some houses have no bedrooms or something like this. So we will analyze this later on. So there might be some missing values. So for bedroom there are some missing values. We'll have to do something with that missing values so that we can get a good prediction from it. The total bedroom number will also affect the our median house value prediction. So this is a major factor. So actually somehow houses usually have bedrooms. So there maybe while data collection some bedrooms were not there or missing due to some reason. So now we are using the matplotlib library to plot a histogram plot for the whole data set to show the data distribution. So you can see the longitude, the distribution, the latitude, and the maximum values for longitude, latitude, and house median age, whole number of bedrooms, rooms for all the like 20,460 rows, 20,640 rows. So this shows the data distribution. So there are 50 bins are there. So this partially shows the portion of the data set. Then we are using np-random.sys to make the notebook's output identical at every run. So now we are using sklearn to for the train trace speed of the dataset. So we'll have to split the dataset into train and test. Because if we use all the dataset for training, this will actually not be a good choice. So in machine learning, we split the dataset into training and test. So normally the 80% of the dataset is used for training and the 20% is used for test. Because oftentimes, actually, if the model sees the whole data, so in real life, when it cannot actually generalize well to new unseen data, so we will have to test to make sure that our model is performing well. So it's like, for example, we when we give an examination, so we don't see the question beforehand, right? So we train on the available data we have, then we are given a new form of question or data to test our skill. So this is something like this, that we'll have to test our model's skill, that how much better it has learned, or it has just memorized, or like it is overfitting or not. So to test this, we cannot show the whole data set to the model. We show 80% of the data set for training, and then we test the model accuracy, that how well it performs on nuance in data, because it might memorize for the data it has seen, but when it will, so that is the our main target, that how well it performs on new unseen data. So do you want to test that? So we are here, we are splitting this using this method def split train trace. So here we are using random permutation to split our data. So here we are shuffling the data. So what is the reason actually for this using this random permutation and shuffling the data set? So actually this ensures that taking actually we are taking random permutation. So randomly it will select a portion of the data set here. So here we are taking 80 20% of the data set, for we are holding it for testing purpose. So you can see that there are 16,512 rows for training and 4,128 for testing out of 20,640 rows. So but there is a problem. If we like take the data randomly, there might be a problem. So we'll explain it soon. So here we are in this part, actually we are using something called a hash map function. So actually what we are trying to do here, so since we are using random permutation, so we need to make sure that at every run, So at every run we get, actually the test set remains consistent across multiple runs. So if I again refresh the dataset and run the code again, we need to make sure that every time the test set is the same. So if when you are using random permutation in our next run, it might change. So actually computing a hash of each instance identifier and putting that instance in the test set, make sure that the data set remains consistent across every runs. So actually understanding this hash function in detail is out of the scope of this video, but what we need to know from this part is that we are doing this so that our test set remains consistent across multiple runs, so that we are using this hash function so that our data set remains, actually our the portion which we are taking for test set remains consistent. We are not like taking the test set for in one run. We don't want that our test set in one run is picked from the first 10,000 rows, and then in the next run it is picked from the last 5,000 rows. So this actually doesn't make the whole process more valid. So this is a pretty actually long tutorial. So I'm actually trying to split this part of this regression video into multiple parts. So I'm actually ending this video here. So I will make another video which will be the regression part 2. So see you in the next video. In the next video I will talk about the remaining part of this code, and we will surely see some more exciting things out there. Thank you.